So this question says that a farmer wishes to build a pen adjacent to a barn. The pen will have 3 sides, and the farmer has a total of 60 feet of fencing. We want to draw a diagram labeling the width as X and the length as Y. So let's do that. We have a barn here. Then there's some kind of a door leading off for his livestock. And he has a total of 60 feet of fencing. We said let the width be X and let the length be Y. So we've done that first part of the question. Then it says construct an equation using X, Y, and 60. Well, we know he has a total of 60 feet of fencing. So what do we have? X plus Y plus X equals 60. Adding those 3 sides together, the 4th side will be a wall of the barn. So now I have 2X plus Y equals 60. So I have successfully come up with an equation that relates X, the width, Y, the length, and 60, the total amount of fencing that we have. What's the next question that we're asked? Solve for Y. Okay, that I can do. If I solve for Y, we'll subtract 2X from both sides. And we get Y equals 60 minus 2X. That's done. Next it says construct a function for the area of the pen. Well, what is area? We know area is length times width. Well, the width is X and the length is Y, so the area is XY. But I just want a function of X. I want A to be a function of X. So that would be X times Y, but we know what Y is. Y is 60 minus 2X. So I can distribute the X and I can have area as a function of X. So area of X is 60X minus 2X squared is our area. I want to find a value of Y that maximizes the area of the pen. So find a value of X first that maximizes the area of the pen, and then Y. So let's talk about that. We have A of X is 60X minus 2X squared. So let's see that. And that is a quadratic function, and it's a parabola that's opening downwards because the squared term is negative. And let's rewrite that as A of X is negative 2X squared plus 60X. So, and we know for our vertex, we know that the X value of the vertex is negative B over 2A. So in our case here, B is the multiplier on X. It will be negative 60 over 2A over 2 times negative 2. So we get X is negative 60 over negative 4, which is a total of 15. So that's the X value that we need. The X value that maxes the area of the pen, fine. We'll say X equals 15 feet. We know that X equals 15 feet. Now, how about the value of Y? Where do we get Y? Where do we get Y? Well, we had this equation right here. Y is 60 minus 2X. So if I know that X is 15, I can say Y is 60 minus 2X. So Y is 60 minus 2 times 15. Y is 60 minus 30. So Y in this case is 30. So the picture that we need, right, we have our barn picture here. the x is 15 and the y is 30 feet. X is 15 feet and the y is 30 feet. Now, the other question that we're asking here is, what is the maximum area of the pen? So again, we know y equals 30 feet. Now, the maximum area of the pen, we could have gotten that from our area function, right? We said area as a function of x was negative 2x squared plus 60x. We found the vertex, the highest point here, happened when x equals 15. But what is the area when x equals 15? I could plug that 15 in and see what we get. What is a of 15? Negative 2 times 15 squared plus 60 times 15. So area of 15 is going to be that. Negative 2 times 15 squared plus 60 times 15. And I get 450. So in terms of our question before, what is the maximum area of the pen? Well, at that vertex, x was 15 and the maximum area was 450 square feet. Now, there's another way I could have gotten that. Remember, we said here that the x value that gave us the maximum, the vertex of our function was 15, and we said the y value was 30 when we did 60 minus 2x. Of course, the area is just x times y, right? Area is x times y. That's the area of a rectangle, length times width. So the area here would be 15 times 30, and again, we get the same answer we had before. Area is 450 feet. And I want to show you one other way we could have done this, and that's using the graphing calculator. So we'll find the maximum of this function, this area function. So let's pull up the graphing calculator. Put in y equals 60x minus 2x squared, fine. 60x minus 2x squared. We want to go ahead and establish our window. We believe x has to be 15, so I don't know, maybe go from like negative 5 to 25. 15 will be in the middle there somewhere. Scale it by 5. Y represents area. It's got to get all the way to 450. So maybe negative 50 to, I don't know, 600. Scaling it at 100. Let's take a look at our graph. So there it is. We want to find the maximum value. Remember, the x value represents the width, but the y value here represents the area. Second calc maximum finder. A little bit to the left. Enter. A little bit to the right. Enter, and then the guess. Enter, and what do we have? Indeed, 15, 450 was our vertex, which is what we said before when we did our negative b over 2a, we had x was 15, and we plugged the 15 into the area function to get 450, so that our vertex had x of 15 and an area of 450.